Okay, today we're going to do part one of our inequalities, and we're just going to practice a little bit with some quadratics. So what our order is to remember is a quadratic always needs to be set equal to 0. So all of these numbers that are over here on the right side of our paper are going to get moved to the other side of the inequality, and then we're going to read what the inequality says once it's in factored form. All right, here we go. So that -3 for problem 1 is going to get moved over. Remember, it's going to be a positive 3. So this is going to be x squared minus 6x minus 27, and that has to be greater than 0. What that means is our outputs have to be greater than 0. So, of course, this is going to factor to x minus 9, x plus 3. Remember, it has to be greater than 0. So our x values, our inputs, are going to be a positive 9 and a -3. And remember, it's a quadratic, so those x values, those are x-intercepts. So what we're going to do is we're going to analyze just the x-axis and kind of do some sign analysis. So I'm going to draw, it almost looks like it's going to be a number line. I mean, you can call it a number line, but we're really going to pretend it's the x-axis. So I have a -3 over here, 0 somewhere over there, I'm just estimating. And then remember, your positive 9 is going to be all the way over there to the right side. And then we're just going to do sign analysis. And we need to make sure that we make the inequality true. So if I plug in anything lower than a -3, let's pretend I plug in -4 for both of these. If I plug in -4 right there, that's going to be a negative number. So when I plug in -4, I'm going to have a negative. And then if I plug in a -4 right here, I'm also going to have a negative. That's going to be a -1. So a negative times a negative, remember, is going to be a positive. And that's what we wanted. So I know that this portion of the x-axis would be shaded if I graphed the full inequality on a coordinate grid. Over here, let's test in between -3 and 0. So I'm just going to test -1 because it's easy to do in my head. When I plug in a -1 right there, that's going to be a negative answer. When I plug in a -1 right there, that's going to be positive. And guys, remember, a positive times a negative is a negative, and that is not going to be greater than 0. So that is not what we want. Let's go ahead and test the other side of the positive 9 right here. So this time I'll just plug in 10. So if I plug in 10, guys, that's going to be a positive times a positive, which is what we want because we want them greater than 0. So if I had to write this in interval notation, which I do have to, we do have to write this in interval notation. So remember, our interval notation to show all the possibilities for x to make the inequality true, that's what we're representing here. So it is going to be, oh my marker, -infinity. That's a -infinity sign. Let me see if I have something else that works. I guess I'll just write in this color. All right, -infinity all the way up to that -3. But remember that -3, we're not going to include that because it wasn't part equal, so put parentheses around it. So remember, we had this portion that was true, or we have this little end piece down here that was true. So I'm going to use my or symbol, and remember, this is going to be 9 to positive infinity. And then that's it. Let's go ahead and take a look at example number 2. I would box that in if I had a highlighter. Let me grab a highlighter because it's so nice to box in your answers. All right, let's go ahead and move on to problem number 2. That 20 is going to get moved over to the other side. So we're going to have x squared. I'm just going to get rid of that because I keep trying to use it. X squared plus 5x minus 14 is having to be less than 0 this time. So I'm going to go ahead and factor, and y'all, that's x plus 7, x minus 2. So of course we're going to have x to equal a -7 and a positive 2. And remember, this time we want our values to be less than 0, so we need a positive times a negative, essentially. So let me go ahead and draw the x-axis again. Remember, it is a parabola, and the parabola is going to cross it somewhere at -7, not somewhere exactly at -7. It's also going to cross it at a positive 2. And we're just going to do some sign analysis. So if I plug in anything less than a -7, like a -8, that would be a negative. times the negative, because -8 would make that -1, -8 would make that -10. Negative times the negative is a positive, and we don't want that. So now let's try the middle section. In between -7 and 2, 0 is my favorite number. I always want to try 0 when I can. So if I plug in 0 right there, that's 7 times -2. That's a negative, which is what we want. And then, of course, on the other side, I'll just plug in a 3. When I plug in a 3, it's going to make both of those positive, so the product's going to be positive, so we don't want that. So this time, if you notice, we just want this middle section right here. So again, if I shaded the U, it would be everything inside the U, or the parabola, which is the shape of the quadratic. So let's go ahead and write that in interval notation. When we write this in interval notation, it's just going to be -7 with parentheses and a 2 with parentheses, and that's it. So remember, when you draw your number line, if you have a middle piece shaded right there, you're never going to use an or sign. If you have these end pieces shaded, you're always going to use an or sign. And for inequalities, I have one more tip for you. For quadratic inequalities, one more tip for you. So if you notice, when I was ready to solve, it's solve ready, I'm ready to go here, this inequality symbol was open towards the problem. When it's open towards the problem, it's an or statement. If you notice over here, when it was ready to be solved, this line right here, the inequality symbol was open towards the answer. And if it's open towards the answer, it's most likely an and statement, which it is. -7 in between -7 and a 2. So that's pretty much how that works. Let's go ahead and take a look at number 3. I dropped my pen. I'm sorry. All right, so for problem 3, please listen, guys. I never, ever, ever solve a negative variable because I always forgot to flip my inequality signs. So see how this is a -2x squared? I am moving all that stuff to the other side because I want my highest degree to be positive. So I'm going to rewrite the problem to look like this. 0 is going to be greater than or equal to positive 2x squared minus 10x. Remember, that stuff was already there, so I'm just going to recopy it. -2x and then plus 16. Let me go ahead and combine my like terms. So 0 is going to be greater than or equal to 2x squared. That's going to be a -12x plus 16. Okay, so if you guys notice, everything has a GCF. We have a GCF of a 2, just a 2. If I have a GCF of a 2, when I'm solving, y'all, the 2 just goes away. If I had an x for a GCF, completely different situation. But if it's just a 2 that I could factor or divide out, I'm going to get rid of that 2. So the mathematical way to do this is to multiply both sides by a half, because that's going to knock out that 2 right there. So here's where it's solve ready. So it's going to be 0 is greater than or equal to x squared minus 6x plus 8. Remember, that's when it's solve ready. So I'm going to kind of analyze my inequality symbol. Notice my inequality symbol is open towards the answer, so I should have an and statement that looks like that. So let's go ahead and factor. So let's see, that's going to be x minus 2, x minus 4. So our x values are going to be a positive 2 and a positive 4. So let's analyze what's going on here. All right, again, so I'm going to plug in some sign analysis here. And this time we want our output to be less than or equal to 0, which means this stuff, the output needs to be negative. So even though the inequality symbol is open on a different side, don't let that concern you. Just remember you're reading what the output should be. And this says the output should be less than or equal to 0. All right. So let's see, I'm going to plug in something over here to the left of it. 0 is my favorite number. Going to plug in a 0 there. That would be a -2 times a -4, which would be a positive 8, and we don't want that. So I'm just going to remind myself that that section would not make the inequality true. In between positive 2 and 4, let's just plug in 3. So when I plug in 3, that's going to be a positive 1 times a -1, which of course is a negative answer. which is exactly what we want. So I'm going to remind myself that's the section we want. And again, on the flip side, I'll just plug in a 5. And when I plug in a 5 on this side, both of those are going to be a positive, guys, which means they're going to be greater than 0, and that's not going to make the inequality true. So again, remember back here it was like, that looks like it's going to be an and statement because the inequality symbol was open towards the answer, and it seems to flow with that logic because we want this middle piece right here. Don't forget that this was part equal, so we're going to use brackets in our answer. So this is going to be 2 to 4. All right, very last one, guys. What we're going to do now is we're going to have, this is like a multi-step problem, guys. Even though this is in factored form, I have something over here dangling on the other side. So if I'm trying to make everything equal to 0, I have to undo that factored form because I'm going to have to combine like terms. So I do need to go ahead and multiply this out. So when you multiply it out, it's x squared minus 8x plus 16. I'm going to recopy the rest of the problem. So the 4 is going to move over. So when I subtract 4 from both sides, I'm going to get x squared minus 8x, and then that's going to be a positive 12, and I need that to be greater than or equal to 0. So for this, we are going to have it factored to x minus 6 and x minus 2. And then just a reminder, guys, right here, the inequality is open towards my problem, so it should be an or statement with the two things at the end that would make the inequality true, the two sections at the end of each number line. All right, at the end of each arrow. All right, so x is going to equal a positive 6 and a 2. So again, if I graph this on a number line, or really it's an x-axis where I'm analyzing where it crosses the x-axis. All right, so if I plug in something less than 2, again, my favorite number is 0 whenever I can. That's going to be a negative 6 times a negative 2, which is going to be a positive output, which is what we wanted. So I'm just going to remind myself that that is the good section. In between 2 and 6, I'll just plug in 3. When I plug in 3, this is going to be a negative number. That's going to be a positive number. Negative times a positive is a negative, not greater or equal to 0, so that's going to be a false section. And then, of course, if I plug in anything greater than a 6, both of these are going to be positive numbers multiplied together, which is what we want. Okay, so to write this in interval notation, remember you have two end pieces. When you have two end pieces, you got to remember two things. You're going to have infinity, and you're going to have your or sign. So this is going to be negative infinity to that 2. Ooh, look, that's part equal. That should have been a bracket. Let me fix that. I'm going to use my or symbol, and then I just did it again. That's a bracket too. Make sure it's a bracket. 6 to positive infinity. So that is how we are going to assess the inequalities that are true for quadratics. Just remember to check your number line, kind of just make a check if it's true, make a little X to remind yourself it's not, and then please write your answers in interval notation and please box them in.